Hello my dear students, I welcome you in the discussion of some simple questions on C-13 NMR which appeared in various GATE exams. Now to begin with, let us consider one example which appeared in 2022 this year. There was one question that it was given dye-substituted anthracene and was asked to find out the number of signals or peaks in proton decoupled C-13 NMR recorded at 25 degrees centigrade in CdCl3. Now simply if we look at the given structure, then it is clear that that compound can be divided into two equal halves. So therefore the how many number of different carbons appeared in one side, those number of signals only will come. So it is clear that in one side 8 different carbons are there. So if we record the C-13 NMR of this particular compound, then we are going to get the 8 peaks. Now coming to the next question of similar pattern which appeared in GATE 2021, that it is a tetra-substituted aromatic compound having a benzene ring, and here also they are asking to calculate the number of signals which will appear in the H NMR. So approach is same only. By investigating the structure, we have to find out how many different environments are available for the total number of hydrogens present in the molecule. So it has been observed that although it is a tetra-substituted molecule, but only 3 environments are there. So therefore if we record the H NMR of this compound, we are going to get the 3 signals. There are 3 ketomethyl groups are there in this molecule and the 2 aromatic hydrogens are there. So although there are 3 ketomethyls, but 3 ketomethyls are not same to same. These 3 ketomethyl groups are divided into 2 environments. The 2 ketomethyl groups which are adjacent to the bromine, they are similar and will give one signal. That another COCH3 group which is para with respect to bromine, that will give the another signal, and the 2 aromatic hydrogens are same to same, they will give the third signal. So this is the accountability of this molecule, how it will give the 3 signals in its H NMR. Now coming to the next question which appeared in GATE 2020, that in this question also they are asking the product P will give how many C-13 signals in its BB spectrum. The only difference is in this case the question is based on the one chemical reaction, means it is one ketone is the substrate and that ketone is allowed to react with the 2 equivalent of sodium hydride, means that is the base. So if it is reacted with the base, then alpha carbanion will be generated. But if we look at the structure of the substrate, then it is clear that there are 2 different alpha positions are there next to the C double bond O, but one alpha position does not have any alpha hydrogen. So carbanion will not be generated in that side. The other side there is CH2. So these 2 hydrogens will be abstracted by the 2 equivalent of sodium hydride. Now when the alkylating agent, means the methylating agent, will be added to these 2 methyl groups will be 2 methyl groups will be incorporated at that particular dianion side. So therefore we will be getting the product where at the alpha position of the C double bond O we will be having the geminal dimethyl group, and that will be the product P. Now after investigating the product P, we have to see how many different carbons are there, means how many carbons are there in the different environment. So total this molecule, means the product P after alpha methylation, what we have got has the 11 carbons, but the 11 carbons are divided into the 8 environments. So therefore the BB spectrum of this product P will give the 3 singlets. Now coming to the question in the 2019 appeared in that exam, that here also they are asking how many signals will appear in the H NMR of the given compound. Now in this case it is a para disubstituted compound and having what it is called the different environments for the all hydrogens present in the molecule. Now this question is little tricky because this is the first example which I have started discussing from 2022. This is the first example where we will be having the diastereotopic hydrogens. If any compound contains diastereotopic hydrogens, then in the H NMR they will give the different signals. At the same time, if we have the diastereotopic carbons, then in the C-13 NMR those diastereotopic carbons will give the different signals. Now this question is based on H NMR, so we have to find out the different environments for hydrogens, not for carbon. So this molecule contains only 2 aromatic hydrogens. So but these 2 aromatic hydrogens are same to same, so these 2 aromatic hydrogens will give one signal. There are 2 CH3 groups are there which are attached with the benzene ring, they are also same to same, so these 2 methyl groups also will give one signal. This compound contains ester functional group, so OCH3 will give the another signal. So in this way we have the 3 signals, and then coming to the another CH3 group which is attached with the oxygen containing ring, so that will give the 4th signal. So A, B, C, D which I have labeled in the structure, these will be the 4 signals. Now coming to the CH2 groups which are present in the oxygen containing heterocyclic ring, these 2 hydrogens CH2 group, it is appearing that they are diastereotopic because one hydrogen is cis to the CH3 group, another hydrogen is trans to the CH3 group. Cis and the trans, they are diastereotopic, so therefore these 2 hydrogens present in the oxygen containing heterocyclic part will be having the 2 signals. So previously I have discussed about the 4 signals. Now because of these 2 diastereotopic hydrogens, we will be having total 4 plus 2 is equal to 6 signals. So this molecule in its H NMR spectrum will give the 6 signals. Now coming to the another question appeared in GATE exam of 2019. If we know one simple formula, then we will be able to answer such type of questions. So this question is like this: in a 400 MHz 1 H NMR machine, a proton resonates at 1560 Hz higher than that of TMS. The chemical shift value of this proton is dash ppm, means we have to calculate the chemical shift value of a particular hydrogen in ppm, which is giving the signal at 1560 Hz in a 400 MHz machine. So to calculate such type of the question, there is only one formula is there, that is chemical shift in delta ppm is equal to chemical shift in Hertz divided by operational frequency in megahertz. So the left hand side is the question mark, so chemical shift in Hertz is the 1560 divided by 400. So if we do, that answer will come 3.9 ppm. So now let us focus on the another type of simple memory based question appeared in 2017 GATE exam. So the question is like that, that is C-13 NMR of acetone D6 has a signal at 30 ppm as septate in intensity ratio. Means if we look at the structure of the acetone D6, then it is clear that this molecule contains 2 different types of carbons. So one is the C double bond O, which appears approximately 200. So they are not talking about that signal, they are talking about the CD3 signal, which is appearing at approximately delta 30, and the multiplicity of that signal where the carbon will undergo the coupling with deuterium, 3 deuterium basically, and the signal will appear as a septate. They are asking the intensity of that particular peak by using the formula of M is equal to 2Ni plus 1, where number of deuterium is 3. So here, and I value of deuterium is 1, so that septate means 7 is coming like this, and the intensity ratio will be 1:3:6:7:6:3:1, means the option 2. So if we remember certain values, certain formulas, easily we will be able to answer few questions. So now coming to the one more memory based question which appeared in the 2016 GATE exam, that is the LARMOUR frequency of 1H at 1 Tesla is 42.57 megahertz. If gyromagnetic ratio of 1H and the 13C are 26.75 into 10 to the power of 7 radian per Tesla per second and 6.72 into 10 to the power of 7 radian per Tesla per second respectively, the LARMOUR frequency of C13 in megahertz at 1 Tesla will be. So this question is also based on a very simple concept. We know that gyromagnetic ratio is directly proportional to the LARMOUR frequency of the concerned magnetic nucleus, means higher the gyromagnetic ratio, higher will be the LARMOUR frequency. So the gyromagnetic ratios of 1H and the C13 were given. If we investigate only the value 26.75 into 10 to the power of 7 and another one is 6.72 into 10 to the power of 7. So it is clear that 1H is 4 times having gyromagnetic ratio than C13. So if we calculate the LARMOUR frequency of C13, then also it will be 4 times less than the LARMOUR frequency of 1H, which is given as 42.57 megahertz. Now what they have asked to calculate is the LARMOUR frequency of C13. So keeping LARMOUR frequency of C13 in the left hand side, the other all symbols appeared in the equation. If we put it into the right side, all the data will be available in the right hand side, means we know the gyromagnetic ratio of carbon, we know the LARMOUR frequency of hydrogen, we know gyromagnetic ratio of hydrogen also. If we put all these things and calculate, then it will come as a 10.69 megahertz, means which is 1/4 of LARMOUR frequency of 1H. Now coming to the another question which appeared in the year of 2013 GATE exam, that we have to find out the number of signals in C13 NMR of proton decoupled C13 NMR of benzonitrile. Benzonitrile means in the benzene ring one hydrogen is replaced by the cyano. So therefore if cyano carbon is the one will give one signal and it is a monosubstituted benzene, so we will be the 6 aromatic carbons will give the 4 signals. So 4 plus 1 is equal to 5 signals. So the C13 NMR of this benzonitrile will be having the 5 signals. Now coming to the question which appeared in the GATE 2014, that we have to identify the product based on the C13 NMR data of the product. Now this is if we investigate the substrate and the substrate is undergoing the interaction with the light, and so it is a very popular reaction. The substrate means the diazoketone will undergo the rearrangement to give some ester, and because that is again confirmed from the given C13 NMR data, because the ester is giving the signal at delta 175 ppm. So based on this, A and B are no way possible, the answer will be either C or D. So whether it is C or D, then so this if we investigate the values other than 175 ppm, means the 52, 50, 46, 37 and the 33 ppm, then these are very clear that these data 52, 50, 46, 37, 33 will not fit into the cyclohexane, means the option D. So A, B already we have cancelled and now we are cancelling the D, so therefore our answer will be C.